Dear friend, good morning. Myself, Dr. Mano VWA, presenting my research paper on ubiquitous computing, a comprehensive review in the track of artificial intelligence and Internet of Things. Introductions. What is a ubiquitous computing? It is referred to the concept of integrating computing technology seamlessly into the environment and everyday object, making it pervasive and invisible to the users. The vision behind the ubiquitous computing is to create a computing environment where every device and systems are interconnected and work together to enhance the human activities and experience. The goal of a ubiquitous computing is to enable information and communication technology to be seamlessly integrated in our daily lives, making it more efficient, convenient, and simple. Now we come on the history of a ubiquitous computing. In the 1980s, Mark Weiser introduced the idea of a ubiquitous computing as a response to the dominance of large mainframe computers and desktop PC. In his earlier work at the Xerox PUCs, Weiser ideas start gaining attention when he developed the tabs and pads, which was the earlier prototypes of a small devices based on a user context. After 90s and in and 2000s, mobile devices are came in a market, which are the part of a ubiquitous computing. Mobiles devices become more mobile and accessible to the every human beings, and concept of a pervasive computing is expanded behind the desktops behind the desktop to include the laptops, smartphones, and wearable devices. From 2000, Internet of Things are started, which saw the integration of a sensor, actuators, communication technologies in everyday objects, creating a network of interconnected devices. And concept of a smart homes and smart city are emerged, which with a device like thermostat, lights, transportation system being connected. The key features and principle of a ubiquitous computing. First, embeddedness. Computing capabilities are integrated into everyday objects, making them capable of processing, sensing, and communicating data. Second is connectivity. Ubiquitous computing are interconnecting, allow devices to communicate to each other and share data seamlessly, and this can be achieved through the wired and wireless networks. Third is context awareness. Ubiquitous computings are designed in such a way they are aware about their context in which they are operating. They can sense, gather information from their environment such as location, temperature, user preferences to adapt and provide the personalized experience. Fourth is our adaptability. Ubiquitous computing systems are flexible, adaptable to changing conditions. They can adjust their behavior and functionality based on user needs and preferences. Last is transparency. The technology in a ubiquitous computing is means to be invisible, keep simple, seamlessly integrated into the environment and everyday object. Users should not have to focus on a technology itself, but rather on the task and activity they want to accomplish. There are a certain motivation behind the ubiquitous computing. First is enhancing user experience. Ubiquitous computing aim to seamlessly integrate technology in our lives, providing enhanced user experience by making technology intuitive, personalized, and contextually aware. Understanding the principle and concept behind the ubiquitous computing can lead to the design of more user-friendly and efficient system. Second is enabling technological advancement. Ubiquitous computing require advancement in a various area, including networking, sensor technology, data processing, and artificial intelligence. Addressing societal challenges. Ubiquitous computing has potential to address the societal challenge in areas like healthcare, transportation, and energy management. Shaping the future. Ubiquitous computing is integral part of an ongoing digital transformation, shaping the future of a technology and society. By studying the ubiquitous computing, researcher can actively participate in defining the direction of a technological advancement, ethical consideration, and policy framework related to its adoption. There are a certain models in a ubiquitous computing. First, Mark Weiser, which is called the three-way model. First is related to mainframe computer and batch processing. Second wave related to personal computer and human computer interaction. Third wave related to ubiquitous computing. Next model is a context awareness model. In this model, we emphasize on the context in understanding and adapting to the user environment, and it involves the sensing and gathering contextual information such as location, time, activity, user preference, and using this information to provide personalized, contextually relevant services. Second, calm model. Calm In a calm, computing is considered as a utility and view the computing as a utility is similar to as electricity and water. It suggests the ubiquity computing resources should be readily available and accessible on demand, allow the user to use the computing power and services whenever, wherever they need it. Next is smart environment model. This model focus on creating a smart environment which are equipped with a sensor, actuator, and communication capability to collect and process data, enabling and personalized context-aware interaction. Next is centralized versus decentralized model. In this model, explore the distribution of a computational resources in a ubiquitous computing system. It consider whether the computing power and intelligence should be centralized in a central server or distributed across the different devices and objects in the term of efficiency, scalability, and autonomy. Next is person action model. This model emphasizes on the importance of understanding the relationship between the person, their action, and the context in which they occur. Next is ambient intelligence model. This model focuses on creating the intelligence environment that are sensitive, adaptive, and responsive to the needs and preference of the individuals. It aims to create an environment that can anticipate and fulfill the user needs by using a embedded intelligence and context awareness. Next is augmented reality model. This model combines the reality and virtual world by overlaying the digital information on the user perception of a physical environment. Now we come on the enabling technology in a ubiquitous computing, that are a Internet of Things and sensor networks. The integration of a IoT devices and sensor network continue a prominent area of research for various applications, like in a smart city and healthcare monitoring and environment sensing. Second is as and fog computing, where researchers are working on optimizing a resource allocation, data caching, task overloading techniques. Next is context-aware computing, we are also exploring that are also used in the some personalized domain, healthcare, smart homes, and intelligent transportation system. Human-computer interactions that are focused on designing intuitive and seamlessly interface for interacting with a small environment. Artificial intelligence and machine learnings that are very useful to improve the data analysis, prediction, and decision making capability in a smart system. Last is security and privacy, that is very much important, which helps for developing a robust authentication and encryption mechanisms, as well as privacy preserving techniques to protect user data in IoT and ubiquitous computing systems. There are some challenge we are facing in a ubiquitous computings, that are in a privacy and security, for which we need to ensure that the security against the unauthorized access, data breaches, and malicious attacks. And the second is data management and ownership, that is also very important, because data is a very clear, critical, clear guideline. Regulations are required to address the data ownership and data sharing and user consent issues to protect the individual rights and prevent misuse. Interoperability and standard that is also very much important between a very different ubiquitous computing system. Energy efficient designs, optimization techniques, including lower power hardware, energy harvesting, power management strategies that are very critical to mitigate the energy consumptions in a ubiquitous system. Also, ethical and social implications faces by the ubiquitous computing. So, we have finding a solution for it. Also, human factor and user acceptance that is also very critical to it. So, ensuring a usability, simplicity, and intuitive interactions with the technology that is very much important. Trust and reliability is also one of a important factor. Legal regulatory challenge that is also very much important. So, we need to take a liability for the autonomous system and regulation for data sharing and use. Last is culture and societal impact. Understanding the culture and societal implications of ubiquitous system is very much important to ensure they align with the societal values, respect diversity, and promote inclusivity. There are some future directions and emerging trends in edge computing and edge AI, artificial intelligence, and machine learning, ethical and responsible ubiquitous computing, integrations of a virtual reality and augmented reality, sustainable and energy efficient design, security and privacy enhancement, user centric design and user experience, cross domain collaboration and integration. Now we come on a final conclusions. Ubiquitous computing offer a transformative possibility by seamlessly integrating technology in our environment and everyday objects. It has a potential to enhance the user experience and improve the efficiency and provide personalized and context-aware services. But there it faces some challenge like privacy, security, and interoperability and energy efficiency that are addressed to be address it so that to ensure the responsible and sustainable deployment of the ubiquitous system. Thanks.